Hi, welcome back to Physics Teacher, the channel that prepares you for the Waterloo University Math, Physics, and Chemistry contests. This is the last question from the Cayley contest in 2021, which is the grade 10 math contest. Give it a try, and I'll be right back with the solution. Alright, so in this question we have two known points, J and K, and an unknown point, L, where L has the coordinates RT, and RT must be within this square. Also, this triangle formed by the points J, K, L must have an area that is less than or equal to 10. And then as we find all the different possible L's that'll make that true within this blue square, we need to find out what that total area encompassed by all those possibilities will be. It says this is what the area is, and then we need to add A and B to get the solution. Alright, so let's start by finding the distance between J and K. So to find the distance, we can use the Pythagorean theorem, or the distance formula. So JK is going to equal the square root of 2 minus 5. Okay, so I'll take the difference of our x coordinates, 2 minus 5 squared, plus the difference of our y coordinates, 7 minus 3 squared, and we end up with 5. Okay, so this distance here is 5. This means that if the area of this triangle, which we can write here, the area would be 1/2 base, which would be 5, times the height, which would be h, must be less than or equal to 10. Alright, so while rearranging for this, we can figure out that h must be less than or equal to 4. So that's our starting point right there. This value h, or the height of that triangle, must be equal or less than 4. Alright, next let's look at the slope of jk. So the slope I'll write is m for jk. So this is rise over run. So first the distance in our y coordinates would be 7 minus 3. And then our x coordinates, 2 minus 5. And that gives us a slope of minus 4 over 3. We can use this slope and the points to figure out what the equation of this line is that connects j and k. And if we do that, so minus 4 over 3 would be some point on the line y, minus a known point, let's use j, so 7, over an unknown point x minus that known coordinate 2. Alright, so rearranging, we get minus 4 times x minus 2, so I'm just cross multiplying here, equals 3 times y minus 7. And then multiplying through, we have minus 4x plus 8 equals 3y minus 21. And rearranging into standard form, we would get 4x plus 3y equals 29. So that's the equation of this line here. Alright, next what I'm going to do is, since I can form any triangle with a height of 4 above this line, it would all be connected to a line parallel to that line. So any triangle where I choose L within this square would give me a height of 4 from the base. So what I want to do is find an equation for this line that I just drew there. Now I know that the equation for that line is going to be parallel. So the equation is going to look the same. We'll have 4x plus 3y. But instead of equaling that to 29, it's going to be equal to some constant c, because it's been translated up a certain number of units. So in order to find c, we first need to find a point on this line. So let's look at k. And I'm going to draw a perpendicular distance from k. So I know that that distance is going to be 4. And let's call this point here P. And then I'm going to just form a right angled triangle here. Let's call that point here Q, where at Q we have a 90-degree angle. Now since I know the slope of this line is minus 4/3, the slope of KP, so the slope of KP is going to be the negative reciprocal of minus 4/3, which would be positive 3/4. So this would be similar to a triangle that looked like this, where we had your rise of 3, run of 4, and that would be a 3, 4, 5 triangle. So this triangle here, PQK, is a similar triangle to the one I've just drawn here. And so what I can do is I can compare those similar triangles to figure out what KQ and PQ are. So let's start with PQ. So we're just going to compare ratios. So PQ, so this length, whatever that is, divided by 3, is equal to this length, which we know is 4, divided by this length, which we know is 5. So rearranging for PQ, we get 4 times 3, which is 12, over 5. And I can do the same thing to figure out what KQ is. So KQ, this distance divided by 4, is equal to 4 divided by 5. So we know that KQ is then going to equal to 16 over 5. And this is going to allow me to figure out what point P is. So point P, what we can do is start at K. So for example, its x coordinate, which is 5, and then move over along parallel to the x-axis to Q, 16 over 5 units. So we're going to add 16 over 5 units. And that start at the y coordinate for K, which is 3, and move up PQ units, which is 12 over 5. And so this gives us the point P as 41 over 5 and 27 over 5. Well, now that I know what point P is, I can actually solve for C in this equation. So we'll take 4 and substitute the x coordinate of P, which is 41 over 5. And now add 3. Substitute the y coordinate, which is 27 over 5. And that's going to equal C. So putting that into our calculators, we get C equal to 49. So we know the equation of this line here is 4x plus 3y equals 49. And if you repeat this exact same method, you could find the lower limit, or the equation for this line, where L can be placed inside the blue square, where the triangle that it makes will have an area of 10 or less. And its equation turns out to be 4x plus 3y equals 9. All right then, so what we need to find then is the area enclosed by these parallel lines. And so what we can do is find the area of the entire square and then subtract it by the area of this top triangle and the area of this bottom triangle. And then we'll have the answer we're looking for. So to find the area of those triangles, what we need to find are these points. Let's call this A, B, C, and D. So to find point A, we're going to use the equation of this above line, which is 4x plus 3y equals 49. And we know that the y coordinate for A is going to be 10. So what we can do is sub in 10 into y to figure out what the x coordinate would be. So that's 4x plus, well, 3 times 10 is 30, equals 49. So 4x will equal 19. And so x is going to be 19 over 4. So this point right here, A, is going to be 19 over 4 and 10. All right, let's find B. Now B is going to have this x coordinate of 10. So what we'll do is we'll substitute 10 in for x into this same equation. So we'll have 4 times 10, which is 40, plus 3y, which equals 49. So that gives us 3y equals 9 or y equals 3. So B is going to have an x coordinate of 10 and a y coordinate of 3. Now we can do the same thing for C and D, but we're going to need to use this equation for this parallel line. So that's 4x plus 3y equals 9. Alright, so for C, we know the x-coordinate is 0. So we're essentially solving for the y-intercept here. So that leaves us with 3y equals 9, or y equals 3. So the point C has coordinates of 0 and 3. And D, we're essentially finding the x-intercepts, which we will change y equal to 0. And when we do that, we get 4x equals 9, or x equals 9 over 4. So the point D has the coordinates 9 over 4 and 0. Now that we know those coordinates, we can find the area inside. Now to do that, we need the area of the entire box. And this is a 10 by 10 box, so the area of the entire box is 100. And then we need to subtract the area of this triangle below. So we're going to subtract 1/2 the base, which has a length of 9/4, times the height, which has a height of 3. And then we're going to need to subtract the area of this top triangle here, which is 1/2, and the base, which is going to have a length of, well, 10 minus 19 over 4. Times the height, which is going to have a height of 10 minus 3. And when we plug that in, we get an area of 313 over 4. So that's the area we're looking for. So now we just need to put it in terms of this equation here. So I'm going to change the numerator to 300 plus 13. And the denominator I can change to 40 minus 36. So that means A, this value here, is 13, and B is 36. So when I find A plus B, you do 13 plus 36, which equals 49, or our answer is D.